Okay, welcome everyone to the session Educating Actuaries in Data Analytics. I think the numbers are just sort of slowly coming up. My name is Bartosz Piwcewicz and I'll be chairing this session. I have both personal and professional interests in data analytics, having worked in this space for some time and also as a convener of the Data Analytics Practice Committee. I'm passionate about the value that actuaries can bring to this space, and developing data analytics capabilities of our members is one of the strategic pillars of our strategy. So before we start, there is some housekeeping that I would like to cover. So you can ask your questions through the Q&A function that is at the bottom of the screen, at least on my app. We'll pause halfway through the session to answer some of your questions. And also towards the end, I think it's 5 minutes before the end of the session, there'll be a feedback survey popping out on your screens. Look, I have a great pleasure to introduce Amanda and Mike. Amanda is a member of the Institute of Actuaries education team and a highly valued member of the Data Analytics Practice Committee, and I have pleasure working with Amanda for some time now. She brings her passion for teaching and 20 years of actuarial experience to these roles. Amanda's current work is focused on redeveloping the actuary and fellowship subjects, including the new data analytics principles and data analytics applications subjects. And we also have Mike. So Mike leads the Actuaries Institute team responsible for development and delivery of the new education program. His team has developed and are now delivering 6 new subjects and are in the process of developing further 5 subjects in the coming months. Prior to joining the Actuaries Institute, Mike has had a mix of actuarial and education roles, so brings a wealth of experience. I mean, he had a role with the Monash University to set up a Part 2 course. He had roles with AMP and Deloitte in Australia. And then also prior to migrating to Australia in 2009, he was a head of actuarial function in one of the European life insurers. So look, so we have quite a lot of slides to cover and quite a lot of good sort of content to discuss. So I will now hand over to Mike to start. Thank you so much.
Okay. Thanks, Bartosz, and thanks for everyone to joining us today. We're going to talk about how we're introducing data analytics into the education program. I'm going to spend about 5 minutes giving you some background and some context of the education program and outline why and how we're introducing data analytics. Amanda's going to talk for about 35 minutes or so, explaining the detail of exactly what we are doing. So a brief reminder that we have gone through a rebranding exercise, and so we have some new names. So Amanda and I will refer to fellowship, whereas you may be thinking of Part 3, etc. It's useful to give a very brief overview of the professional development where we take people from age about 18 to the newly qualified status. We have an extensive curriculum, which, as you all know, is split up into 3 parts. The first part, the foundation program 14 University, introduces lots of techniques to students that involve very simple models that enable us to pose well-defined problems that have well-defined answers that often use, although not exclusively, analytical techniques. Once they go through that stage, they come to the actuary program, which is primarily the control cycle, and we teach students how to stand back from a problem and consider all stakeholders. For those that continue, they enter the fellowship program where they specialize in a particular domain. And largely what we're trying to do there is we're testing them that they can think critically, that is, they can apply judgment. So as you can see, the actuary program in the middle is a bridge between the foundation and the fellowship, and that's its purpose. But it also has a very important thing of explaining to students that the well-defined problems are actually a bit too well-defined. We set a trivia question to explain this using a wider field, and it's no pun intended, that we asked the question, which planet is closest to Earth? Is it Venus, is it Mars, or is it Mercury? And we're going to show a quick video that explains. And so non-intuitive answer.
My very easy method just speeds up naming planets. Every physics classroom has a solar system line like this, or like this. Sorry, Pluto. Looking at the line, which planet is closest to Earth, Venus or Mars? To answer, you need first know that, like many things in school, the line is a lie. Planets are not people queuing for coffee, but rather spheroids scattered in space, always in motion, not in simple circles either, but in ellipses at untidy angles. In the cold, dark expanse, this is the coziest Venus gets to Earth, but only about once a year and a half-ish. Starting close, she orbits far, then comes back, needs some space on the other side of the sun. This means when Venus is away, Mars can be the closest to play. So because of orbits, there isn't one answer to who is the closest. It's really who is mostly the closest. The mostest closest. When Mars and Venus are both on the other side of the sun, it leaves little Mercury the closest. Each of Earth's inner 3-planet friends are, at one time the farthest and the closest. And Mercury, with his smallest orbit, makes him never that far from Earth, at least on planetary scales, giving the little guy a uniquely close relationship with Terra. In fact, watching the planets spin, because of his small orbit, Mercury, not Mars or Venus, is the closest planet most of the time. Looking at the line, that seems impossible, but nonetheless, in the way of actual orbits, if we keep measuring the distance to all the planets as they spin, Mercury is Earth's mostest closest neighbor, which is delightfully unexpected. But wait.
Oh, thanks, Amanda. As shown in that video, we start off with a question or an exemplar, a map, if you like, that shows that something we all saw in junior school, distance from the sun. But as soon as we changed the question slightly, we had to spend a lot more time trying to figure out what the question actually meant. It necessitated building a more complicated model, and the two physicists who answered this question, they made some simplifying assumptions that the paths were circular rather than elliptical, and the planets were coplanar. But they did something that you'd be familiar with from a pricing or reserving perspective. To solve this question, they didn't look at an analytical solution. They just developed a computational tool that projected forward the paths for the next 10,000 years and then came to their conclusion. When we continue the journey to the fellowship, what we're trying to do is get students at the newly qualified level to operate in the blue boxes, essentially where the training program or the education program is helping students become experts who are on tap rather than experts who are on top. The structure of the education program for many years has really focused on us extracting information from data in order to validate a select few variables. However, as we're all aware, there's been a huge rise in computer power, a massive reduction in data storage costs, which has led to a significant increase in data capture. And organizations are now asking, I have this data, what does it tell me? This is essentially a new question, so it's like a new paradigm, but it doesn't replace the existing classical approach that we use. It's a complementary approach. And students are coming in to us and saying, it is a fascinating question. How do I extract that information? Which requires new techniques. So our old techniques don't work because they were for a few variables. We're looking at many variables. And our solution is to introduce a compulsory subject at the actuary level that considers many of those techniques that are used to extract information from data. Further, as part of the wider fields initiative, we're introducing a specialist subject called data analytics application. I'm going to hand over to Amanda, who's now going to explain in detail what these two subjects are.
Thanks very much, Mike, and thanks for explaining why we're introducing new data analytics subjects into the actuarial curriculum. So I'd like to talk about 3 components of that education program. I'll start by talking about the data analytics principles subject. I'll then talk about the new fellowship subject, as Mike said, which is called data analytics applications. And finally, I'd like to give some advice for those of you who might be well past your formal actuarial education days, but are interested in learning some of these topics as part of your CPD. So I'll give you some advice about how to do that. So I will start with the data analytics principles subject. I joined the Institute's education team about 2.5 years ago, and ever since then I have had lots of questions from students asking when data analytics subjects will be ready for the program. So that means I'm really excited to be able to say that data analytics principles is now being studied by students at university as part of their actuary program. The aim of this particular subject is to extend students' knowledge of the tools and techniques that they've picked up from the foundation program. So within some of the statistics subjects that they've taken, they've learnt about exploratory data analysis, linear regression, generalised linear models, and they've also had a brief introduction to topics such as penalised regression and decision trees. But the focus within the foundation program, as Mike sort of alluded to, is on the theory of these models and some simple sort of closed form applications of them. What we want to do in this subject is help students to apply this knowledge in real life business settings across multiple domains. And they'll mostly be doing that using the R programming language, which universities have elected to use. A secondary aim of this subject is to help prepare students for more complex and practice-specific applications that they'll be required to adopt within the fellowship program. So if they're studying the general insurance or life insurance subjects, they will be required to call upon this knowledge from data analytics principles within those subjects. I think we've already mentioned that this subject is being taught by universities, our accredited universities. And what I really liked about the approach that we took to develop the syllabus for this subject is that it was really collaborative. So we had expertise from industry practitioners like Bartosz and others on the Data Analytics Practice Committee. And that was combined with expertise from educators so that we could come up with a subject that was as effective and enjoyable for students as possible. And that process started with the Data Analytics Practice Committee putting together a massive wish list of every topic they felt that actuarial students needed to know within the data analytics area. And really, when we showed that to universities, they said that's 2 or 3 years worth of study at least. So what they helped to do was to reduce the scope of that syllabus into something that would be realistic to teach within a single subject. And that has resulted in a syllabus that looks like this. The syllabus that we've come up with for this subject is designed around the data analytics process. So most of you won't be unsurprised to see the 5 elements that are included within the syllabus. So the business environment, data, modelling, evaluation, and communication. But what might stand out to you from this diagram is that we've placed the business environment in the centre of the process. And that's because the Data Analytics Practice Committee keep reminding me that this is such a vital element, being able to understand the business environment that you're working in. It's vital across all stages of the analytics process. So what I'd like to do is spend a little bit of time fleshing out what we're planning to cover and what universities are already starting to teach for each of these 5 components of the subject. And what better place to start than right in the middle of the diagram, which is the business environment. Okay, so the emphasis of this component is to help students understand that the business environment has a really critical role across all aspects of data analytics and the data analytics process. So whether you're trying to articulate the problem to be solved, thinking about the constraints that a business faces, so that might be system constraints or legal rules that you need to follow and a whole range of other constraints that we know we come up against as actuaries working within businesses. When you're trying to gain stakeholder buy-in, evaluate your model outcomes, communicate your results, measuring the success of the model, throughout all of those stages, having a really good understanding of the business environment that you're working within is absolutely critical to a project's success. So as one example, when you're trying to define the objective of a data analytics project, you obviously need to make sure that that objective ties in with the business's objectives and the business's strategies and constraints. You need to discuss those objectives before you even start thinking about what data you might use, and obviously before you start doing any modelling. And then you need to review those objectives over time to make sure that what you're doing in your modelling is still going to meet the business's needs. So clearly that's a really important concept that we need to convey to students when they're learning these new techniques. Students will learn this concept through case studies, where they might be presented with a case study in which a really poor understanding of the business led to the downfall of an analytics project. And similarly, they will have case studies presented to them that highlights where a really good understanding of the business environment actually helped to make the project really successful. Okay, then the next component of this subject is data understanding and preparation. The Data Analytics Practice Committee keeps reiterating that this is a massive component of any actuarial graduate's role. But data understanding and preparation is often a task where the effort and the time required for this work is underestimated. So we were really conscious to make sure that this had a significant enough component within the subject. The aim of the topic is to highlight to students the processes and methods that they can use to understand the data that's available to them, and then to be able to prepare that data for modelling. So within this topic, we'll be looking at data exploration and visualisation, assessing data quality, so through a range of different methods, so high-level checking of your data, spot checking, comparing it to last time's data set, comparing it to other external data sets, and maybe even talking to people within a business, which I know is a little bit of a hard concept for actuarial graduates to grasp, but it's a really important element of understanding the data that you're working with. And then students will also learn how to manipulate data and cleanse it ready for modelling, primarily using R. Which leads into the topic of modelling. The purpose of this topic within data analytics principles is to provide really good foundational knowledge of the common techniques that students are likely to need when they enter the workforce. They can then obviously further build their skill set once they enter the workforce, but the aim here is to give them confidence in knowing where to start. So if they're facing a particular problem, what modelling options are available to them and what might be suitable given the context. And perhaps even more importantly, we're going to give them confidence in knowing where to look for more information. So if they've got a particular problem, they know a model that will be great, but they know they're going to need to tailor that model for the particular situation they're facing. We'll be showing them where they can actually look for information about how to tailor that model. So this topic explores concepts like how to define a target variable, which is not as easy a problem as you might think, feature selection and transformation, being able to split data up into training, validation and test sets, and the very important concept of the bias variance trade-off, which, as you know, is really important across all elements of data analytics modelling. Students will gain a better understanding of common modelling techniques such as generalised linear models, shrinkage or regularisation techniques, and tree-based methods and ensembling. And what they'll need to do is be able to explain those different methods, but also to compare them to each other, be able to select a method based on the task that they're trying to undertake, and then of course apply that method to solve a particular problem. They'll also be given an introduction to neural networks, but they won't be required to apply neural networks for this subject. So the focus of this topic is really on understanding the strengths and weaknesses of different models by taking into account things like the business context and its constraints, how interpretable a model is and how easy it is to explain how it works and its output to other people, how accurate different models are, and how that contrasts with how quick different models are and that trade-off that sometimes is required. How suitable a model is for different data sets. So if you're working with a really big data set, what model might be most appropriate? And conversely, if you've got not very much data at all to work with, what are some of your options? And again, students will consider all of these things through case studies. So they'll be presented with a particular situation within a business and be asked to select an appropriate technique and then justify their selection. Which sort of leads on to the topic of evaluation. What we want students to be able to do is use a range of different perspectives to be able to evaluate the suitability of a model. So they will have already learnt some statistical measures for evaluating a model. We want them to understand a range of different statistical measures, but to consider the most appropriate measure given the business context that they're facing. So if I perhaps give you an example of what I mean to illustrate this concept, in different situations, the cost of false positives and the cost of false negatives arising from a model could be quite different. So if we're in a pandemic situation, I sadly don't need to say if anymore, we are in a pandemic situation, someone might be doing some modelling or creating a model that helps to evaluate whether anyone coming into a country from overseas is sick or not. And that obviously can inform decisions around putting someone into quarantine. In that particular situation, it might be or it is really important actually to have low false negative rates. And what I mean by that is a low number of sick people that go undetected and therefore enter the country and spread the disease. But if we're in another setting, for example, if we had built a machine learning model to try to identify emails as either or classify emails as being spam or non-spam, in this situation, it might be more important that any real emails are actually received into your inbox. So in contrast to the pandemic example, in this situation, it might be more important to have low false positive rates, i.e. you want a really low number of non-spam emails that are actually sent off to the spam folder and therefore not read. So those sorts of examples will help to illustrate to students that different measures are needed to evaluate different models depending on the business context that they're facing. So once again, I'm harping on about the importance of the business context. Then the final section of this subject is communication. Most of us, or in fact, I would say all of us know that in order for results to be insightful and valuable, we need to be able to communicate them in a way that the audience will understand them. And that's particularly important when you might need the audience to be implementing recommendations from your model, or you might be trying to persuade your audience of the importance of the findings from your model. So what we want to do is help students to know how to communicate their findings in a way that is clear, but also fit for purpose, and takes into account things like the motivations of their audience's biases and beliefs, and the audience's communication style preferences. Now, there is another subject called communication modelling and professionalism that has been introduced into the Actuary program alongside data analytics principles. And that CMP subject will cover the topic of communication and presenting to a range of different audiences effectively in a lot more detail. But we nevertheless felt it was important to reiterate this concept within this data analytics principles subject. So at that point, before I move on to the next data analytics subject, I would like to pause for a minute and just see if anyone has any questions on this subject. Bartosz, have we had any come through the Q&A yet?
Yes, we have one question. How much time and effort is required to learn R? Under what circumstances might it be more appropriate to develop facility in Python? So probably a little bit more technical question.
Yep. I will touch on that a little bit later on in my presentation, because we actually teach the data analytics application subject in Python, because we think it's important for students to know both R and Python. I don't know what your experiences are like in the workplace, Bartosz. Is one more popular than the other at the moment?
Well, certainly Python has been more popular in the sort of data science space. Having said this, when you look at some of the statistical analysis, I think R is still sort of seen as potentially more powerful in certain applications. But then even with Python, you can refer or you can call R scripts as well. So yeah, at the end of the day, you can really sort of use both. But yeah, it does really depend on the organization and what sort of their sort of strategies, in terms of technology and the sort of technology stack that they want to use.
And in terms of how long it takes to learn either R or Python, it depends on how proficient you want to become. I think I will talk at the end of my presentation about some CPD options, including how to pick up skills in programming. And I think there are lots of online courses you can do.
Yep.
You know, a subject that takes you an hour, you can do something that might take you 4 hours across 4 weeks. And that just gradually builds on your skills. But I think I have found in learning R and Python, there's a very steep learning curve, probably like most topics. But then I imagine eventually it gets much flatter and you can, you know, can use it much more easily. But I do find it quite hard at sometimes when you're not so proficient in R and Python to have to force yourself through solving a problem using a language that you're not as familiar with.
Absolutely, absolutely. So we have another question that has come through. How long is the whole course going to take?
So the data analytics principal subject is a single subject. So students will spend 1 semester studying at university.
Okay. Look, we'll have another opportunity just to sort of ask questions and have a bit of more discussion at the end. So let's continue with the course and with the presentation, and we'll just jump again.
Okay, sounds good. All right, so hopefully that has given you a sense that the compulsory data analytics principal subject obviously focuses on each stage of the data analytics process, and having an understanding of the business environment is a core principle that impacts all stages of the data analytics process. I'd now like to move on to the optional data analytics applications fellowship subject. And as you can see from the picture behind me, this subject is currently under development. It will be launched in semester 2 next year. It has been developed and is being developed with significant input from members of the Data Analytics Practice Committee and other experts. So what I'd like to do is give you a relatively brief sneak peek behind the curtain while we're developing this subject. The aim of the data analytics the data analytics application subject is to show students how to apply a range of data analytics skills, but being able to combine this with their professional judgment. And Mike talked before about a focus in the fellowship program being to give students a deep knowledge of a particular topic, but showing them how to actually apply that knowledge using their critical thinking skills or their judgment. And students will combine their technical skills and their professional judgment to be able to solve complex and challenging problems throughout this subject. Students will be exposed to a number of quite new or new to them at least, and perhaps more niche tools. So they'll learn about neural networks, which are only covered quite briefly in data analytics principles, natural language understanding, unsupervised learning, and business problem optimization, which sort of pulls all those old and newer techniques together into one module. And we'll be presenting these techniques through a range of different case studies drawn from a wide range of industries. So we're currently planning case studies in the area of government services, retail. We will have some insurance and financial services case studies, and then possibly even industries such as energy and environment. What we want to do is open students' eyes to all the different industries that they can potentially apply these skills within. So as I was talking about before in response to that question about whether you should learn R or Python, I actually think it's really important that students learn both. So both R and Python are popular data science tools. And Python, similar to R, is very versatile and flexible, very powerful, easy to use, and both R and Python are open source, so they're free to use. And so we felt that it was important that students wanting to go down this data analytics stream have exposure to both R and Python through the education program, which is what they'll get if they choose to study data analytics applications. So the application subject has 3 key topic areas. The first is business environment. You may not be surprised about that, given how much I've harped on about that in relation to data analytics principles as well. And within this topic, we'll cover a range of really important considerations that students need to take on board for any type of modelling that they're doing. There's then a modelling applications component, which will contain a little bit of theory on some new methods and lots of examples of practical applications of this theory. And then the final topic or key area of the subject is around championing change. And that really relates to looking at the actuary's role in bringing together all of the other topics that have been covered in this subject and even in data analytics principles to help promote and champion change within an organisation. I'll talk a little bit more about that in a minute. So what I would like to do is now look at each of these three topic areas in turn. So you can probably see from that picture behind me that there is quite a bit within this business environment topic in the subject. The first component, domain knowledge, obviously builds on knowledge that we've covered in the data analytics principles subject. But the emphasis here is not just on why domain knowledge is really important to acquire, but how do you go about doing so? So we'll talk about a range of different methods that students can use to acquire domain knowledge, particularly if they're looking to move into a new area that they don't have any experience in. They might conduct initial online research. They might ask questions, again, of real people, really pushing students out of their comfort zone, having to speak to people in a business. Joining knowledge communities, so maybe meetup groups or online knowledge communities that really focus on a particular topic of interest. And then some of you might have been to a summit session that Martin Moquer was running, which talked about being able to understand customers. And so one idea that he picked up on, which is included in this subject, is walking in the shoes of users. So if you're wanting to gain some domain knowledge in the area of, say, banking, you could go and visit your local bank and apply for a home loan and just see what that experience is like through the customer's eyes. The second area within this topic is ethics, security, and privacy. And we'll be talking to students about why these concepts are really important, not just in data analytics, but across any aspect of actuarial work. We will cover security and privacy principles that are jurisdiction agnostic, so they're not necessarily based on rules within Australia, but these principles are the foundation for many of the rules that are adopted in different countries. We'll then present different ethical perspectives and frameworks and teach students concepts like ought before can. So just because something is legal, it doesn't mean that it's the right thing to do or that you ought to do it. We'll teach them concepts of fairness, and that relates to being able to define what you mean by fairness, which is not an easy thing to do. And then based on a definition of fairness, evaluate whether your model is in fact fair. And we'll also talk about concepts such as making sure that your model is fit for purpose and that you have appropriate responsibility and accountability frameworks in place around any work that you're doing. We will also talk to students about different rules that exist in relation to ethics, security and privacy. So things like the Australian privacy principles, the EU's General Data Protection Regulation, and rules such as the California Consumer Privacy Act. So just to give them a taste of the sorts of laws that are now in place in different countries. And then the final component of this topic is data architecture. And our aim in including this in the subject is definitely not to try to turn students into data architects. I think we would be silly to try to do that in a short space of time at least. But it's more about helping actuaries communicate their data needs to data architects so that they can have a successful two-way conversation. We will cover topics such as data and database concepts and terminology, the link between data and business activity. So if a student is presented with some data to use in their analysis, making sure that they can work through a process to understand what has actually created that data and what part of the business does that data represent, so they can get a really good understanding of the data that they're using and perhaps based on that, how reliable or not that it might be. We'll talk to them about effective data workflows and pipelines, and we'll also cover concepts such as real-time data flow and cloud data. That then takes us into the second key topic area for this subject, which is modelling applications. Within this topic area, we'll be firstly reminding students of the modelling techniques that they've picked up in data analytics principles. So we don't operate on a set and forget basis in our education program. What students have learnt in previous subjects is, prerequisite and required knowledge for current subjects. So we'll remind them of some of those things that they, might not have studied for a year or two. We'll then present them with some new modelling tools and techniques. I've already mentioned these ones: neural networks, natural language understanding, unsupervised learning, and optimisation of business outcomes. And what we really want to do is teach them a little bit of the theory behind these tools and techniques, but also to present a lot of case studies so that they can get an appreciation of how those tools and techniques can be used in complex and challenging situations to solve problems. So some of the case studies that we're thinking about using include neural networks being used in customer churn modelling, and obviously having an understanding of why your customers either stay with your business or leave is important across almost any industry and any business. Natural language understanding will be looked at in terms of customer analytics. And some of you might have been to a session that Michael Storozhev ran, talking about using natural language understanding to understand customer complaints within travel insurance. So that's one particular case study that we'd like to bring into this subject. We'll look at the use of unsupervised learning in outlier and specifically in fraud detection. And then within the optimisation topic, we want to pull together students' knowledge from all the different techniques that they've learned and present two different case studies. One of them will be focused on optimising a business outcome, such as maximising or optimising profit for a business. And another will be focused on optimising a societal outcome. So one idea that we have is optimising hospital bed allocation, which is obviously an issue, at least at the moment, within the public health sector. So that should give you a taste that we'll be teaching these modelling applications with a little bit of theory so that students understand what's going on within the models, but through a whole lot of practical application, so students really know how to use these techniques in a business setting to solve real problems. So our final topic within data analytics applications is championing change. And that has two key components. The first one relates to how to successfully deploy a data analytics project, taking into account things like the needs and requirements of your customers, management, maybe admin and IT, and a range of other stakeholders within a business. So that's very specific to deploying a particular project or model that you've been involved in. The second topic, our second subtopic here, is related to being a data analytics champion at a higher level within an organisation. So different businesses are at different levels of data analytics maturity. And what we want students to be able to do after completing this subject is start to be able to influence change at an organisational level to help move businesses along the data analytics maturity spectrum. So there's obviously a lot of really interesting topics in the data analytics principles and data analytics application subjects. And we think these topics are really important for students who are wanting to apply data analytics successfully within business. But what about those of you out there, either watching live today or watching a recording, hopefully years down the track? What if you're already qualified as an actuary, or what if you've left your formal study, well behind you? What are CPD options for you if you're interested in learning about some of these topics? And so that's what I'd like to cover. We all know that CPD is very important for all actuaries. We need to make sure that we keep up our skill set, make sure it's kept up to date and that it's still relevant. So if you're interested in learning about some of these topics that I've presented through either data analytics principles or data analytics applications, there are many, many options available to you, which can be a little bit overwhelming. In order to work out where to start, if you're interested in learning some of these topics, I'd encourage you to think about how you like to learn as a starting point. So some of us like a really highly structured approach. I think that would be my preference, where the pace of study and the topics that you'll cover are potentially set out for you by someone else or by a course. Others of us prefer a more self-paced and self-directed mode of study. And maybe that suits you better if you're working long hours, you've got kids at home, and you really need to be able to pick and choose what you'll study when. Obviously, that second option requires a lot more self-discipline, but is a little bit more flexible as well. So I'll talk through some options for each of those study preferences. The first one, if you prefer a really highly structured approach, then I'd strongly recommend that you look into studying the data analytics principles subject through an accredited university. You don't have to undertake a whole university course to do that. You can choose just to study the data analytics principles subject. You then might decide to study the data analytics application subject through the institute. And I've got another option for you, which I think is really exciting. You're getting sort of advance warning or advance notice of this new exciting opportunity. The Institute is currently developing a CPD certificate course in data analytics. It's being developed in partnership with an Australian university. It will have key topic areas that are aligned to the data analytics principles and data analytics application subjects. And it's going to be launched early next year, so you don't have too long to wait before that will be ready. And then if you have a whole lot of time on your side, then you could choose an option like studying a Masters of Data Science through a number of different universities in Australia or overseas. So that's another option that's available to you. If, unlike me, you prefer sort of some self-directed study, or if you just simply can't wait until the data analytics applications or the CPD certificate course is available, then you could still use the syllabus that's available for data analytics principles. That syllabus is available on the Institute's website. You can use that to identify your current knowledge gaps and perhaps give you an idea about what topics you might want to learn first. So once you have an idea of where your knowledge gaps are, you could then use a number of different sources to try to fill them. So I'll give you just a few examples of where you might look. The Institute's data analytics monthly newsletters are usually packed with a whole range of different articles. We usually have a theme for each newsletter. So there was one on ethics. I think we've got one coming up on diversity. And within those newsletters, there's heaps of different articles that you can be sent off to start upskilling and learning on that topic. There's also Actuaries digital articles that cover a range of different topics. And in particular, we run code snippets articles that present a case study, show you the code that was used to try to solve a problem within that context. And so you can work alongside that article to reproduce that code and reproduce the answer. There are also external publishing platforms such as Medium. So I get a daily notice of new interesting articles related to other articles that I've read on Medium. That's a great way to just hear about new topics that you might not otherwise come across. And the Actuaries Institute is also always running different insight sessions, and we're currently working on some masterclasses in data analytics that we'll be running from next year. And if you do have ideas for particular topics you'd like to hear about through the insight sessions or masterclasses, Bartosz and I and other members of the Data Analytics Practice Committee would love to hear them, so please get in contact and let us know. There are also meetup groups that you can go to. So there's meetup groups such as Data Science Sydney and Melbourne, and I think they have a data science meetup in every major city, at least in Australia. And then other meetup groups like Our Ladies in Melbourne, I've been along to before, so it's becoming quite specialised. I think they do actually let men into that group as well. If you're wanting to learn about R or Python or another programming language, there are a lot of online options. So DataCamp, Code Academy, and lots of other providers can give you, either a single subject or a whole course that you could take in a programming language. And then there are other online courses such as the machine learning course offered by Stanford University. So I've taken that one through Coursera and I found that really helpful. There really are lots of online options. If you prefer to have a break from technology for a little bit, there are even book series that you can read, such as O'Reilly and the For Dummies series, if you're interested in coding. And there are other data analytics textbooks, such as Introduction to Statistical Learning in R, or The Elements of Statistical Learning, which are really useful starting points. And they do give you some structure to your learning. So regardless of whether you like a really structured approach to learning, or you prefer to create your learning path yourself, I think having a hands-on experience component to your learning is really important. So you won't learn enough by just taking online courses but not doing anything yourself. you really need to be practicing your coding and practicing the application of techniques yourself. So you could do this through entering a Kaggle competition. So Kaggle is an online data science competition. There are hundreds of different competitions on offer at any point in time. Or another option that I've come across recently are data science internships. And I found one that's offered by Quantium, that's a virtual internship. So you sign up online, you receive a set of data, and you use that data to answer some questions from a customer and then put that together into a report. So I found that a really useful way to practice some of my coding skills. And then my final option is if you've got a project that you're working on at work or a model that you've seen built at work, and it's in Excel and you can really see that it might benefit from being transitioned to R or Python, have a go at doing that. That would be a great way to practice your coding skills, but do something that could really benefit the business that you're in as well. And in any of those hands-on learning experience environments, Stack Overflow or other websites that help to answer any questions really related to data science and coding, they'll become your best friend. So as a key takeaway point in relation to continuing professional development, I would recommend that you just start somewhere. There is an overwhelming number of topics and options for you to start learning. Just pick something and start. And even if you then head in a different direction, at least you will have made some progress. And I think what you'll find is that our actuarial training, even if it's been a long time since you've studied or several decades like it is for me, it will come back to you quite quickly, and it sets you up really well for learning some of these concepts. And it really isn't so hard once you get started. You've just got to make that start. All right, so I think you've probably heard enough from me now. So I'd just like to say in conclusion that whether you're an actuarial first-time student or whether you're an actuary who is interested in continuing your professional development in the area of data analytics, the Institute's education program I've hopefully demonstrated to you has something for you. The data analytics principles, data analytics applications, and CPD certificate courses contain so many different data analytics topics that are really invaluable to actuarial students and qualified practitioners alike. So hopefully Mike and I have given you lots of inspiration about getting started in your data analytics learning journey. And at that point, I'm interested to hear what questions or comments you have about anything that we've talked about. So I'll pass to Bartosz to facilitate that discussion.
Thank you, Amanda. Hopefully everyone has found this very informative, insightful. So we have quite a few questions. I will probably just go from the top of the list. I mean, some of them I think are probably a little bit harder. So we have, so the first questions I'm looking at is, I found exchanging views and techniques with those data scientists that specialize in data science at university very valuable, and to learn from one another. Any such exchanges planned for the education program?
Within all of the subjects that we teach, at the moment we're teaching them through the Canvas learning management system, and we encourage students to set up study groups and use discussion forums to share those ideas. We have found, Mike, you might want to comment, that students are a little bit reluctant to have too much of a conversation on that at the moment. That's something we're working on though. I mean, options like Stack Overflow, I guess, provide that option. So someone posts a question and then you often get maybe 10 to 20 people replying to that question with their own version. I find it invaluable. I haven't actually posted questions myself there because usually someone else has already asked the question that I'm asking. So that is one way to facilitate that sort of discussion and learn from each other.
And the principal subject is taught at university, and I suspect that many of the lecturers there and other students in the class will be data scientists, and so there'll be plenty of opportunity to cross-fertilize ideas with other domains.
I agree.
And I talked a little bit about the virtual internships that you can take with organisations like Quantium. So through that program, you complete the task and then you receive a model solution. So that's another great way to learn, is having a look at what someone else has done and just making sure that you understand all the steps in there. So I agree, it's a really valuable way to learn.
That's right. And I think the data science meetups, I mean, they're pretty much open, right? So you can have those conversations as well. And I think that awareness is just sort of going more and more. LinkedIn is a good, I find as well, a good sort of source to sort of get different sort of views. And there are quite a few people with sort of deep data science background that sort of run these sort of channels as well. So I think it seems like there's plenty opportunity to sort of share views and then exchange ideas. That's good. Okay, we have another question. This question is, I think it's just sort of thinking about it. So how important is it for me to make sure I build my skills as I have limited coding experience? So just, looking at the investment to the future and, and just how do you balance, I think, all of it?
I think in years gone by, I think the majority of older actuaries learned a lot of different coding at various points in your life. You were just thrown a machine and the boss said, go and do it. But I was fairly unstructured when you had less competition around. These days, many people come into the world of work either with some knowledge of R or Python or certainly Excel. And it's just part of life. Sometimes we forget, we take these exams to get the credential as a fellow, but thinking that's when our studying stop. You can't as a professional. It just has to continue on all throughout your life. And unfortunately, fortunately, because knowledge is expanding, you've just got to get on top of it. I think Amanda's gave some great tips on how to structure your learning, which is the key thing that stops people, because it seems such a frightening thing. It says, where do I start? So that's it. As soon as you start your journey, carry on with it.
Absolutely.
All of those options that I talked about, you can really tailor them to how much time you have available. And as I said, you can invest in a master's course, which I imagine is, at least 20, 30 hours of study a week over a long period of time. Or you can take a course that requires 1 or 2 hours a week. So it's, you can really tailor it to your situation.
That's right. And I think that example that you sort of gave around turning, I guess, some of the models that perhaps were built in Excel or something else into a model built in Python or R could be a way as well. Just sort of practice some of those, I guess, complexities of structuring a model. So I think there are different ways. I agree. So in terms of those different sort of tips, I mean, are we sort of expecting those to be sort of available somewhere? Published somewhere? So I mean, we have our microsite, right, for the Data Analytics Practice Committee.
Yeah, we do have some of that information available through the Data Analytics microsite, so we can certainly check to make sure that we've covered all the options that I've given. And then there was an article in Actuaries Digital that Rob Daly wrote as well, his journey to machine learning, something like that. So that provides a number of those tips in there. But if anyone can't remember some of the names that I gave, feel free to get in contact with me as well. So you can reach out to me through the Institute and I'm happy to provide some guidance.
Sounds good. We have a flurry of questions. The questions just keep on coming. So is the syllabus out now on the upcoming certificate of data analytics and from CPD program?
Well, I saw it last night because I've joined the program to do the course over the next few weeks. I'm not sure if it's public at the moment.
And so that's the IFOA course. And then the Australian one, we'll be notifying members about that, I think, in the coming weeks. So the syllabus isn't available yet, but it will be very shortly. And I think we're looking for enrolments in that towards the end of this year. So, you'll hear about that very soon.
Okay. We have another question. Will any of the practical modeling be done using cloud environments in those courses?
Well, the modeling that we're planning to do, we have to work out a way to make it easy to share things with students. So we are actually going to be using Google Colab to teach Python through Jupyter Notebooks. That's within the data analytics application subject. So I'm not sure if that's a sort of cloud environment that people had in mind, but that is one use of the cloud to be able to teach these case studies and teach programming and the other concepts within the subject.
Yeah. There's another good question here. I've seen some people say that as a relatively senior actuary, I don't need to study the data analytics myself. My specific domain knowledge is already enough in conjunction with junior staff who can do the techniques. Is this an approach that can keep me relevant?
That's a good question.
That's a very good question.
With an element of luck, yes. You're so senior that you can escape doing the solving of the problems, but I would think that you really would want to understand these new techniques, because we grew up in a world where we knew the answers, if you like. We knew that we were interested in lapse rates. We had macro level data, which would enable us to validate those assumptions. That's where we grew up in. But quite frankly, the businesses these days are just saying, well, I've got all this data on my customers. What does that tell me? And as a senior actuary, you might be thinking, well, that's fascinating, but I don't really know how to answer that question. You don't have to spend hours and hours and hours doing mathematics or the detailed programming, but you really need to get a good handle on what, on how the junior staff are actually answering those questions.
That's right. That's right.
I guess you don't want to become too removed from what junior analysts or analysts within your team are doing, because otherwise their work will become a black box to you. And it, you know, yes, you can look at the output, but it's yeah, it might become quite challenging to really test that what they're doing is reasonable. Which goes to one of the other questions, which is around about using more sophisticated techniques, which gets more difficult to explain to people. And if you're the senior actuary and every senior actuary I've ever worked for, if they didn't understand the technique that I wanted to use, they wouldn't listen to me. Right? So, yeah. But now we're in a world where they're going to have to understand those techniques. And that gets back to the final topic in the data analytics application subject, which is championing change. If you've got analysts in your team that are pushing for change, but you don't necessarily understand what it is that they're pushing for and you can't support them in that, then they may not be successful in implementing that change.
Absolutely. And I think, I mean, as a practitioner, I mean, I can certainly sort of see that some of those techniques that, you know, maybe only a few years ago weren't really that sort of common. You know, they really sort of come with a particular sort of specific purpose. You can use it in the business. So as a senior actuary, it's good to sort of understand, I guess, the nuts and bolts of those techniques. Like, you don't have to necessarily be the best sort of coder there, but, you know, really understand how they sort of work. And then essentially you can make a better judgment if in a particular context actually you can use it. So yes, I think just having that sort of communication and understanding is really, really important, because then you will have to sort of convince the other sort of senior execs in the organization or influence the business direction. So if you don't have that sort of understanding, it really becomes really, really difficult, and it's very quickly can become you know, irrelevant in the business. So, and I think that's what we've been sort of probably seeing in some of the organizations in the market as well.
And it's fun as well. It's great being able to, you know, continuously develop new knowledge yourself and go back to some of, I don't know, like my primary school years when I taught myself coding and then let it go a lot in some of my actuarial work. So I'm loving going back to it again now. Okay, yeah, that's right. Okay, a couple more questions. So more complex and accurate data analytics techniques often come at the cost of less explainability. Is upper management ready to rely on models that are mathematically proved more accurate, but that cannot be explained easily?
You won't get, if you're upper management, you will not accept a model that cannot be explained. You've got too much risk involved. You can't trust a junior person to come up with an answer like that. Yeah, so we need to find ways where we can explain what we're doing. It's always about telling the story, not the calculations itself. People are going to trust that you've programmed it correctly or tested it, that processes in to understand the maths. They're not interested in you as an actuary because you can do maths. They just presume you can do the maths. What they're interested in is your ability to convince them using stories that you've got a good idea that's worth pursuing. And there was a great presentation at one of the Actuaries seminars that we ran a couple of years ago, Bartosz. I can't remember the name of the speaker, but he talked about the importance of taking the business along the journey with you. So not jumping straight from like a traditional technique within Excel all the way through to, you know, some much more sophisticated, harder to explain technique, but building up their knowledge along the way and taking them in little baby steps towards where you want to go. I found that a really useful way to think about it too.
That's right. That's right. Okay, we have the last sort of 2 questions and only 2 minutes to go. I mean, I can see that the feedback poll is already on the screen, so hopefully everyone had a chance to tick the different boxes there. But there's a question around I guess the specialist actuarial sort of techniques and knowledge and how they sort of relate back to finance or data analytics sort of skills, and whether there's that sort of advantage that you sort of bring. So it pretty much goes back to the value proposition of an actuary. I mean, do you have any views on that?
Yeah, I sort of, in the beginning of this talk, explained our key roles is be able to stand back from a problem and look at it from all sides. And Amanda's not going to like me for saying this, to be disinterested in the problem. So you don't look for a solution that you like, you explain the potential solutions and potential pathways to employer. So that aspect of professionalism, I think, sets us apart from many others.
Sounds good. Okay, so maybe just the last question. There are already double degrees with computer science for over 2 decades. That's correct. Have we thought of going down this path without reducing the time taught on traditional actuarial techniques?
Well, the straightforward answer is no, but I think we are going to have to revisit what we do in the early part of the course to enable us to, well, sorry, let me just beginning. The principal subjects is in the actuary level because there's no room for it in the foundation level. You can argue that lots of those techniques should be in the foundation level, and it's something that we've got a bit of constraint on us at the moment, but I suspect in 10, 20 years time, it'd be a very different proposition.
I agree. Okay. All right. Well, look, we've covered quite a lot of questions and quite a lot of topics, so it's been really, really good. Any sort of final points from yourselves to close off the session?
Yeah, I would like to say thank you to a number of people that have been helping to develop both the data analytics principles syllabus and to the universities who have now been implementing that subject and teaching it. But also, if you could just indulge me for a minute to thank a few specific people who are helping with the data analytics application subject. So John Shen at Suncorp has been heavily involved in both of the subjects, and I really can't thank him enough. And a lot of other people who have spent a lot of time and have volunteered a lot of time going forward include Zemming Yu at Munich Re, Dominic Rowe at Covermore, Suzu at Greenstone, Rob Daly, Hugh Miller, Josh Girardi and Peter Mulqueeny at Taylor Fry, Jackie Poon at NRB Travel, Chris Dolman and Dimitri Semenovic at IAG, Andres Villegas Ramirez at UNSW, Elliot Dawson at Deloitte and Zelinka Jiang at Quantium. So as you can see, there's a lot of different input into the subject and even, other members like Bartosz and other members of DAPC who are constantly helping and providing feedback too. So we couldn't do it without them. And then finally, thank you all for watching and for your interest and great questions.
Yeah, I'd just like to say a big thanks to the events team at the Institute for organising this wonderful conference. Thank you.
Thank you. Okay, all right. Hope you guys have a good rest of Friday. There's still one more session to go and the weekend as well. Thank you so much.
Thanks, bye.
Thank you.